Hi, this is page 1 of Friday's lesson, number 69. This is the last new material, and there's some reminders at the top, the factoring patterns we've been learning, and the strategy for solving a quadratic that we worked on yesterday. Today we're going to take some little stories and translate them into equations, quadratic equations, and then solve them. And there's just 5 of them, but they take a little explaining. So we'll start with this one that says the sum of the squares of 2 consecutive integers is 61. You might remember from long ago, with consecutive integers, we call the first number x, and then the next number is x plus 1. So if if you had 17, the next number is 18. 18 is 1 more than 17. So whatever this number is 1 more than the first number. Now, the sum of the squares of the 2 consecutive integers is 61. So if I square the first one, I just give it an exponent 2. To square the second one, very important to remember to wrap it in parentheses. So there's the square of the first number, the square of the second number. Putting an add sign between the two, now we have the sum of the squares of the 2 consecutive integers becomes the equal sign, and we're told 61 is what they add up to. And now all I got to do is solve this equation. And it's not too bad. If you remove the parentheses here, if you multiply out x plus 1 times x plus 1, you're going to get x squared plus 2x plus 1. And now, if we combine these x squares, 1x squared and 1x squared is 2x squared. So we got 2x squared plus 2x plus 1 equals 61. Let's take away 61 from both sides at the same time. 1 take away 61 will give us a minus 60. Now we have a pretty typical quadratic equation to solve. And notice that everything is divisible by 2. So we can reduce the numbers in this equation if we just go straight across, divide every piece of it by 2. We get 1x squared plus 1x minus 30 equals 0 divided by 2 is 0. Now what we need are a pair of numbers that add up to 1 and multiply out to negative 30 to get this factored. So what would those be? How about a plus 6 and a minus 5, right? Multiply those, you get negative 30. Add them, you get plus 1. So the solutions to this quadratic equation then are, since we have this times this equals 0, when does this equal 0? When x equals negative 6. When does this equal 0? When x equals positive 5. Okay, so if we use the 5 for x, if we say 5 is x, 5 is the first number, the next number is x plus 1, the next number would be 6. This is what we say is true, right? Is this true? If you square them and add, do you get 61? Yeah, that's 25 and 36. That does give you 61. What's kind of interesting is that the negative 6 also works. So if we say negative 6 is the first number, what's the second number? The second number is the first number plus 1. Negative 6 plus 1 would be negative 5. And if I square negative 6 and square negative 5, I think you know what's going to happen next. This is going to be positive 36. That's going to be positive 25. They're still going to add up to 61. So there's actually 2 pairs of numbers that satisfy this problem, positive 5 and positive 6, or negative 6 and negative 5. Okay. Now that you've seen that example, number 2 shouldn't look much worse. The sum of the squares of 2 consecutive even integers is 244. Now remember a long, long time ago when we did this, here's even integers, right? And to get to the next even integer, what do? You add 2 to the one before it. So if we say the first number is x, we're going to say the second number is x plus 2. So here's x and x plus 2. I'm squaring them. Notice the parentheses again. Squaring them and summing them is supposed to give us 244. Oh, this is just x squared. If you multiply out x plus 2 times x plus 2, you will get x squared plus 4x plus 4. And now let's combine the like terms and take away 244 from both sides. So we'll have 2x squared plus 4x. 244 taken away from 4, that's going to give us minus 240. Okay? And again, everything's, you got even coefficient, even number. Let's just make our work easier by getting all the numbers smaller by dividing everything by 2. We get x squared plus 2x minus 120 equals 0. And now we need two numbers that add up to 2 and multiply out to negative 120. Maybe you can think of those before I even write them. 12 and 10. 12 and 10. And if we make this the positive and this the negative, see, those will add up to plus 2 and those will multiply out to negative 120. So when does this equal 0? Again, we have something times something equals 0. So we want to know, when does each thing equal 0? This equals 0 when x equals negative 12. This equals 0 when x equals positive 10. And using the 10, the numbers would be 10 and 12. Notice that squaring those would give you 100 plus 144 equals 244. That works. If we use the negative 12, the next even integer would be negative 10. And as in the example 5 minutes ago, look what happens. You still get positive 144 added to positive 100. You're still going to have the correct sum of 244. That's the end of page 1.